So this first part is about basically order of operations, right? And we're going to evaluate some expressions. Remember, order of operations says we first do the grouping symbols. And I know there's like an acronym out there, PEMDAS, right? And I don't really like that term PEMDAS because it, P stands for parentheses, but it's not necessarily parentheses, right? The more sophisticated term for them is grouping symbols. It could be brackets, it could be curly brackets, it could be parentheses, whatever. So you have the grouping symbols, then the exponents, the powers, then we multiply left to right, and then we add or subtract left to right. So let's go ahead and do a couple of these. So evaluate the following. If m is 12 and q is -1, so m is 12 plus 3 minus, okay, so if q is -1, that goes in parentheses squared. Yeah.
On our packet, 3 minus q is in parentheses.
Oh, yeah. It didn't come out? Oh my gosh. Okay.
Oh my. Miss Malika, remember when you used to say that?
Huh?
Oh my.
Okay, so, yes. So when we convert to, thank you for telling me, when we convert to PDF, these things go away sometimes. Okay, that makes it a whole different problem. Thank you. Okay, so 12 plus 3 plus 1 squared, right? Yeah? Okay, so that would be 12 plus 3 plus 1 is 4 squared, so 28. Okay? So stuff like this, you would be expected to do without your calculator. Okay, you're not going to have a calculator available for this stuff, right? Because then you don't need to know how to do it. Okay? But the whole idea is these are things that you should just be able to do mentally. So no calculator for this stuff. Okay? All right. So here we go. M is 12 plus 2 times Q, -1, plus 4. How much? 14 it is. Okay? All right. So fractions, the most important here is just to be, organized, keep your, main fraction intact. J is -1. So do you see how I make that bar first? I put the fraction bar first. This way, everything's aligned. So if J is -1 and is squared, I got to put it in parentheses. Minus 3 times H, 4 squared, times 0.5. So now it's up to you. You can keep it as 0.5 or you can do 1/2. It's totally up to you. And then J cubed, -1 cubed, plus 2. Okay, so we got 1 minus 3 times 12, right? And I always prefer 16, and I always prefer to make that a 1/2. I can't, my eraser doesn't work. All right. I always prefer to write that as a 1/2 just because that's my preference. Okay, so -1 plus 2, right? So this is 8, 23, 24, so 1 minus 24 over 1, -23. Okay, so this is our, how to go from Fahrenheit to Celsius. It's super fun to do it when you have a heat wave, right? Right, and our Israeli friends, right? This is how you can convert 110 degrees Fahrenheit, which is, what we're heading these days, to Celsius, right? And it's like in the 40s, which is pretty bad. Yeah. Okay, so so here we go. What is the Fahrenheit equivalent of 40 degrees Celsius, right? So if it's 40 degrees Celsius, that's that one, and we're solving for Fahrenheit. So Fahrenheit is 9/5 times 40 plus 32, Again, no calculator for this, because the 5 and the 40 will reduce to 8. So we get 72 plus 32 is 104 degrees Fahrenheit. Okay? So when we have 104, right? If you're in Israel or if you're in Europe, that's 40 degrees, which is not fun. Okay? All right, so that's pretty much lesson 1. Right? And like it could be in all sorts of variations. Again, no calculator. Yep.
Do you need to memorize the formula?
For Fahrenheit?
Yeah.
I mean, it's kind of a nice thing to know. I'm never going to ask you for it, but it's very impressive to know. Just, to impress your friends. Okay. So properties of real numbers. This you may or may not have seen before, but it could very easily be covered in Algebra 1, so it's definitely not above any of us. Okay. So in math, right, we have this whole set of real numbers. Basically, all of the numbers, all of the types of numbers that you've been used to deal with since the beginning of your life, these are all part of the real numbers. But they have classifications, right? And that's what we're going to talk about first. Okay. The first thing that we're going to talk about is what we call rational numbers, right? Okay, so if you're talking about a person, right, and you say, he's like very rational. What does that mean? What sort of, like, what does that imply if somebody is rational? Calm, and what else? Reasonable. That just sort of makes sense, right? Right? You can wrap your head around what they say. So that's what rational is. There is like rhyme and reason to this person, right? Rational numbers are the same way. Rational numbers can be expressed as a ratio of integers. Integers are, 1, 3, 7, -2, and so on. And rational numbers are all the numbers that could be expressed as a ratio of integers. So for example, if you have any fraction, the decimal of which ends, terminates, or is a repeating decimal, these are all rational functions. All right? So for example, 1/3 is a rational function. Why is it a rational function? In decimal, this is 0.33333, right? Do you see how there is a rhyme or reason to this? This is a rational number. 1/5 is 0.2, right? It's a terminating decimal. That's a rational number. And then let's say 5/1, right? It could be expressed as a fraction. It's basically 5.0. That's a terminating decimal. That's a rational number. So all of these are rational numbers. So basically what you want to know is in decimal form, they terminate or repeat. Okay, one thing. Middle school teachers love the repeating bar for repeating decimals, right? Like 0.3 with a bar. High school teachers can't stand that bar because in real life, nobody uses the bar, okay? What we do instead, if we have a repeating decimal, we will just round it to the, necessary space, right? So like 0.3, 0.33, and so on. Okay, so in these rational numbers, we have further subsets. We have the integers, the whole numbers, and the natural numbers. Okay, so the integers are basically all of the numbers that have a denominator of 1, right? So 5, -2, right? All of those. -2, 17, 2054, and so on. Integers. Whole numbers are part of the integers, but you take out the negatives, okay? So for example, integers would be, dot, 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 like -3, -2, -1, 0, 1, 2, 3, dot, 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 right? Those are integers. Whole numbers are if you take away all the negatives. So basically it's 0, 1, 2, 3, dot, dot, dot. Okay? Yeah? Okay, Olivia, can you start counting for me? Okay, you always start at 1, right? Yeah, naturally. Nobody starts counting at 0, right? Those are the natural numbers. Some, like back in the day, a long time ago, before you were born, they were also called the counting numbers. So it's basically, you now eliminate the 0 as well. 1, 2, 3, dot, dot, dot. Okay? So, these are all the integers. They basically have a denominator of 1. These are the whole numbers. We took the integers and we stripped away the negative numbers, and you get the whole numbers. Then you strip away the 0 and you get the natural numbers. Okay? Yeah.
So integers is all of them?
Integers is all of them. Negative, positive, and 0. Okay? Okay, so we have the real numbers. Okay? We got rational numbers. All of these are rational numbers. And then we've got the irrational numbers. So if somebody is not, if somebody, if you describe them to be an irrational person, what do you think that means? Not reasonable, all over the place. There's no rhyme or reason to them. Nothing makes sense, right? That's the irrational numbers. So it's basically a ratio of integers which are decimals that repeat without pattern. Okay, these non-ending decimals that they never end. This is 1, right? This is an irrational number because there is no rhyme or reason here and it never ends. Okay, so that's like the most famous irrational number is pi. What else do you think is an irrational number? What's a decimal? What can you think of that is expressed as a decimal that never ends? All right, I'll give you a hint. I'll just tell you. Root 2. What's root 2? 1.14, blah, 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 right? Never ends, no rhyme, no reason. That's an irrational number. And then, like root 15 and so on and so forth, right? A lot of roots are irrational numbers. Yeah?
I was going to say root 3.
Root 3, that's the next one. Root 3, that's the next famous one. So it's there's definitely the classic examples teachers give is pi, root 2, root 3, and so on. Okay? So those are irrational numbers. So, one more time. We've got the entire set of real numbers. This is all the, numbers in the universe that you're used to dealing with until now. That entire set of real numbers is divided into, okay, and so they have these symbols, which I hate, but I don't want to use the symbols. I'm just going to use the words for them. So the entire real numbers is divided into rational and irrational, right? And then the rational is divided into integers, whole numbers, naturals. Okay? So here you have some examples. All right. Name all of the sets of numbers to which each number belongs. So -185, right? What do you think, huh? It's an integer. What else? It's a real number. It's a rational number. And it's an integer. Okay, so you can put the letters now. And then on the test, you can do letters or the words. It's totally fine. I never make my students memorize that, Q is rational and so on and so forth. Okay? So it would be, if you do it with the letters, it would be R, Q, Z. I don't make my student, because no real life math person goes and says, oh my God, so I'm thinking of a Q number, nobody says that. Okay? All right. What about root 49?
Real number.
Uh-huh.
I said
Yeah, go ahead.
real number, rational, and whole.
So what is that? This is 7, right? So it's a real number. Is it a rational?
Yeah.
Yep. It's okay, so if it's rational, it's not irrational, right? Is it an integer?
Yeah.
Yep. Is it a whole number?
Yeah.
Is it a natural number? Yeah. Okay. So it's basic. Okay, so now I'm gonna get lazy and just write an R. Okay, so it's all of them except for irrational. All right. What about root 95? Is it a real number?
Yeah.
So do that first. It's a real number. Okay, spoiler alert. All the ones you get right now are going to be real numbers. Okay? That's going to change after like chapter 4 or 5. Okay? Yeah. So, real number. Okay, so is it rational or irrational? That should be the next level. Oh, now there's a little discrepancy. There's like a little, controversy here. So if you're not going to get a whole number, or you're not going to get a ending decimal like 3.5, 2.7, 5.25, then it's going to be irrational. So this is irrational. Okay, so this is a real number. And then the next level you should ask is it rational or irrational? What do you think? This is a rational one. Because if you can write it as a fraction, it's a rational one. So it's Q.
It's also up there as an example.
It's also as an example. I gotta make a note for myself for next year. Okay? So the irrational numbers, they're basically going to be either they're mostly going to be roots or like the constants like pi and stuff. So when you're classifying these, the first question should be, is it real? Which again, right now they're all going to be real. Question 2 will be, is it rational or irrational? Okay? If it's irrational, it stops. Then if it's rational, you have some more to do. Okay? All right. That's it for today. That's the lesson for today. What I want to do now is I want to talk about what I want homework to look like. So let me give you guys a little bit on that. Here's the syllabus. If I click on it, okay. So if you go here under assignments, right? I've laid out basically how I want the homework to look. And this last bit here, it says you need your name, homework number, lesson number, and assigned problems, okay? Similar to last year. The reason for that is, so this one, if you look on your lesson plan, this is homework number 1, okay? So if this is your name, if this is your paper, you're gonna put your name on here. Now, I am requiring that you put this information on here. Where you put the information is up to you. When I was a student, I had a very specific way of how to set up my heading, and I respect that, And if you have your own specific way, I am not going to get in the way of that. Just give me the information that I want, okay? So you're going to put your name, right? So Mrs. Malikian. I loved doing math homework. Oh my gosh, like I would go back to school just to do math homework all over again, let me tell you. Okay? So what else were we putting on here? Homework number. So this is going to be homework number 1. The reason for that is, this way I know exactly what homework to grade. And then sometimes a student will just mess up and you meant to write 1, but you put 2. And that's why I also want you to say what section number is it. So now today's homework is from 1.1 and then you have another one from 1.2. So here's what you're going to do. You're going to put 1.1 here and then just put the problem numbers, like whatever number I've assigned here. So this is 19, 21, 25, 31, 33, and so on. Again, if you want to put this like this here, fine. If you want to put it on the other side, fine. If you want to put it in the middle, fine. Just put it somewhere in the top. I'm not going to get in the way of your organization, just somewhere in the top. Most of the time, 90% of the time, you're only going to have one lesson to do homework from. So this is going to be how it looks, okay? So today you have 2 assignments, which means, okay, so here, and then you do number 19, write down the problem, like the equation and stuff, right? And then put the work and then the final answer in a box so I know, okay? Even if a problem is something that you can do in your head. So for example, like the last ones, classify these as rational, whatever. Still, write the problem. So say number 17, root 21. Real, irrational, okay? Because all of these answers are in the back of the book. And there has to be a way that I know that you didn't just go to the back of the book and just blindly copy down answers, okay? There has to be a way for me to say that you at least looked on the page where the homework was. So you do this, and then you do number 21, blah, 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 blah. Now you're done with this problem, okay? Go to a new page. It could be in the back or a new piece of paper. Go to a new page, and then just put 1.2, the problem numbers, and start. You don't need the heading for the second page. You can just staple it. Does that make sense?
You don't want to listen to me?
Huh?
You don't want
Well, I want to know where 1.1 ended and where 1.2 began. You see what I mean? Because when I'm grading, let's say I'm going to grade number 21, 33, and then number 21 from section 2. I want to know where section 1 ended and where section 1 began. These are very short problems. It could very well be that you do section 1 on the front of the page and section 2 on the back of the page. Like, don't waste paper if you don't want, you don't have to waste paper, but be very clear on, where one section ended.
Can we start?
You are going to start right now. Another thing, I'll get you in a minute. As far as class participation is concerned, when it's time for you all to do homework in class, there is a reason for that. I could easily give you a worksheet, but I want you to start on the homework so we can address any issues. There is no, oh, I would rather do it at home. Oh, can I work on something else now and do the homework at home? That's class participation. You do what we're doing. I will put up the homework problems on the board right now for you all, okay? Give me 2 seconds, and I will do that. Maybe like 7 seconds. I always have to stop myself and say the right name for you now because, okay, Daniel. Okay, no, in person. So here's how it's going to work. On Tuesday, wait, hang on. On Tuesday is when I see you next. When you come in, the first thing you're going to do after you put your cell phone there is take out your homework and put it on your desk. I'm going to walk around and stamp all of the homework. Okay?
Then you have to keep it.
Then you have to keep it. Yeah, well, we can get through that next time.